So good morning, students. So last class we have studied chemical kinetics, what it deals with. So basically I told you that it deals with the rates of chemical reactions and the factors affecting the rate of the reaction. Okay. Next we have studied the reaction rates. How reaction rates are written? It is the rate of change in concentration by the change in time. Next we have written how it changes. So we have written rate is equal to minus delta A by delta T, which is the change in concentration of A over a time period delta T, and delta B by delta T is equal to change in concentration of the product B over time period delta T. So we have written delta A as negative before the reactant. Why? Because with time it decreases. So we can see from the graph that with time the reactants decreases and the products increases. See, A molecules are decreasing and B molecules are increasing. We have also studied this reaction rates and stoichiometry, how they are related. So we study the reaction to Y to B, then we can write the rate as rate equal to minus 1 to delta of the concentration of the reactant A by dt, or we can write in form rate is equal to delta of concentration of the product of B by delta T. So in general we can write, if this is the stoichiometric way how this reaction, we can write it this way. So we have solved also two numericals. Next, rate laws. Okay, so there are certain rate laws. Remember that rate laws is determined experimentally. Theoretically we cannot study the rate law, and reaction order will come. What is order of a reaction? We'll study in the next class. Is defined as the in terms of reactants and not on the concentration of the products. So reaction order is always defined in terms of reactant, in terms of concentration of the reactants, okay, not in terms of the product. And the order of the reaction is not related to the stoichiometric coefficient of the reaction in the balanced chemical equation. So you can see that when we write the rate is equal to, it is written like this: K into concentration of F2, that is fluorine, into concentration of ClO2 to the power 1. But here we have seen that in the stoichiometric equation, we say that 2 molecules of ClO2 is required for the reaction to take place, but the reaction depends only on the concentration term of single molecule of ClO2. It doesn't depend upon the 2 molecules. So we can see that the order is not the same as that of the, it's not related to the stoichiometric coefficient of the reactant. So it may be related, in some cases it may be similar, but it may not be related. Next, we'll study the factors that affects the rate of a chemical reaction. So the following factors affects the rate of a chemical reaction: temperature, concentration, pressure, surface area, and presence of a catalyst. Now see how the temperature is dependent upon the rate of the reaction. So as we increase the temperature of a particular reaction, so definitely the kinetic energy of that particular reaction will increase. And with the increase in the kinetic energy, the number of collisions, the molecular collisions will be more, and therefore the greater number of molecules will achieve a higher activation energy. That will study this, what is activation energy, that we will study it in the later classes. So just know that the number of collisions will be more, so the reaction will be more particles will react, and therefore the reaction rate will increase, the rate of the reaction will increase. The second factor is concentration or pressure, whatever. So if the concentration is high or if the pressure is high, then more particles will be present in per unit volume. So if more particles are present, then the collision will be more. So if the collision is more, we already know that if the collision is more, then the reaction will be fast, and so the rate of the reaction will also increase. Next, surface area of the reactants or the particle size. Okay, so if the particle size is smaller, then the contact of the particle with the surface area will be more. Okay, and if the contact is more, then again the probability of collisions will be more, and as a result the rate of the reaction will increase. And the last is the presence of the catalyst. So generally catalyst speeds up the reaction of a reaction, speeds up the rate of a reaction, though it doesn't take part in the reaction, but it enhances the rate of the reaction. So as we add a reactant, a particular reactant, as a particular catalyst, the reaction rate increases. Though there are some catalysts which slows down the reaction, or which poisons the reaction, catalytic poison. So there are different, but in general, the role of the catalyst is to increase the rate of a reaction. Okay, so that is all for today. Please go through this, and then we'll discuss. In the next class, we'll discuss some more important things related to this chapter. Okay, thank you.